The paper of the day is Reducing DRAM Footprint with NVM in Facebook. This paper presents MyNVM, a key-value store system designed and deployed at Facebook, which leverages non-volatile memory block devices to significantly reduce DRAM usage in large-scale data center environments. MyNVM is built on top of MyROX, that is Facebook's MySQL backend using RocksDB, and aims to maintain high performance, that is latency and QPS, while reducing the total cost of ownership by substituting expensive DRAM with more affordable NVM. The work addresses the practical challenges of using NVM as a DRAM replacement, including bandwidth limitations, endurance, and OS-level interrupt overhead. The authors introduce several novel system design techniques to overcome these issues and demonstrate through production deployment that MyNVM can reduce DRAM cache from 96 GB to 16 GB with negligible impact on performance. Here are the key contributions. The first production use of NVM in a commercial dataset. MyNVM is the first system to use NVM block devices in a real-world, large-scale data center environment, moving beyond prior work that relied on simulation of byte-addressable NVM. The second is novel system design for NVM integration. That covers a lot of key points like partition indexing, reducing DRAM footprint, NVM bandwidth by partitioning database indices, align fine-grained caching, block alignment, aligns compressed data blocks with NVM pages to minimize read bandwidth and improve latency. And the third is dictionary compression, mitigates the loss of compression efficiency with smaller block sizes and reducing database size overhead. Fourth is admission control, limits writes to NVM to only high hit rate objects, extending device endurance. Fifth is hybrid polling, replaces interrupts with a hybrid polling mechanism to reduce I/O latency overhead. The third is comprehensive evaluation in production. The system is evaluated using both synthetic benchmarks like Linkbench and real Facebook production workloads, showing significant DRAM savings with minimal performance trade-offs. Covering some highlights, the first is dramatic DRAM reduction with minimal performance loss. MyNVM reduces DRAM cache from 96 GB to 16 GB, that is a 6x reduction, while maintaining mean and P99 latencies within 10 to 20% of original, and QPS only 8% lower than the high DRAM baseline. The second is NVM-specific optimizations are essential. That is, naively speaking, DRAM with NVM leads to severe performance and endurance issues. The paper's technique, especially partition indices and block alignment, are critical for making NVM viable as a DRAM substitute. Real-world impact and generalizability. The solutions are not only applicable to MyROX, but can be generalized to other data center systems like Memcached, Redis, that are DRAM-bound, potentially transforming memory cost structures at scale. Now, let's look at some of the key figures. The first is the figure 1, which shows that reducing DRAM cache in MyROX from 96 GB to 16 GB doubles mean and P99 latency, but MyNVM with 16 GB DRAM and 140 GB NVM restores latency close to the original. The table 1 compares DRAM, NVM, and flash characteristics, highlighting NVM's intermediate position in cost, speed, and endurance. Here are some notable quotes from the paper. The first is, our implementation reduces the size of DRAM cache from 96 GB to 16 GB and incurs a negligible impact on latency and queries per second compared to MyROX. The second is, to best of our knowledge, this is the first study of the usage of NVM devices in a commercial data center environment. The paper gets 9 out of 10. This paper is highly impactful, presenting a practical production tested solution to a pressing cost and scalability problem in modern data centers. The technical contributions are both novel and broadly applicable, and the evaluation is thorough and convincing. The only minor limitation is that some optimizations like hybrid polling are not yet fully integrated into production, and further work is needed for multi-threaded polling efficiency. Nonetheless, the work sets a new standard for NVM adoption in large-scale systems.